Priority means whichever the element have the highest value, that element has to be deleted first. That is called as priority queue. Double-ended queue, insertion and deletion can be done from both the ends. The queue either from the front end or to the rear end. F is greater than R. If F is greater than R, that means there are no elements in the queue, so it is in a underflow condition. Hello everyone, welcome to one more session on data structure using C for second semester B.Ca students. We are continuing the discussion on Unit 2. Myself, Indu J, Faculty of Computer Science Department, Vidhyaashram First Aid College, the Temple of Excellence, MYSURU. In this session, we are going to discuss one more very important data type called as queue, which is a non-primitive data type and a linear data type. Let us see what queue is. So we have discussed so many data types, that is non-primitive data types like arrays, stacks, and now we are discussing on queue. In the queue, we have two ends, right? It's exactly similar to the queue where you stand for the movie queue or any other queue, right? To take a ticket of the movie or to enter into any exhibition, you are standing in the queue, right? Same thing that is applied here. There are two ends. From one end, we are inserting the element, and from one end, we are deleting the element. It always gives the priority whose comes first. It works on the principle of first in, first out. Whoever comes the first, that person will be served first. That is a principle what queue works on. Let us see what is queue. Queue can be defined as an ordered list. Right, it is a linear data type. All the elements are stored in the form of sequential order. That's why we call it as a linear data type. Ordered list, which enables the insertion operation to be performed at one end, and that end is called as rear end, and deletion operation to be performed at the another end called as front end. How many ends we have? We have two ends. One is rear end and one is front end. Queue prefers the first in, first out principle. Whoever comes first, first in, first out, that element will goes out first. Okay, for example, people waiting in a line and a railway ticket forms a queue. So different queues you might have seen in the real world, you can apply it anywhere. As when people comes, that first person has to be served first, and then the next person has to be served next. Whoever comes as the last, that will be served at the last. Right? For example, we have seen many queues in the real world. This is how we are going to represent. This is a pictorial representation of the queue. How we are going to represent the queue in the form of diagram. Here we have a front end, and here we have a rear end. Insertion will be taken care by the rear end, and deletion will be taken care by the front end. This is a representation of queue. It is storing the continuous memory block here. All the element will be stored in the sequential memory blocks. So there are different types of queue. How many types of queues are there? Queues are mainly classified into different categories. One is a simple queue, or we call it as a linear queue. One is circular queue, priority queue, and double-ended queue, or we call it as DEQ. DEQ. Okay. So let us see each of these type one by one. What is a simple queue? Simple queue, as I said you, first in, first out, there will be two ends, rear and in the front. From the rear, we are inserting the element into the queue, and from the front, we are deleting the element into the queue. That is a simple queue or the linear queue. The insertion takes place from a one end while the deletion occurs at the another end. It strictly follows first in, first out rule. Right, that is what the simple queue is. Next comes circular queue. What do you mean by circular queue? Here only the change what we have in the queue, we are linking the last node, last element with the first element of the queue. In circular queue, all nodes are represented in circular manner. It is similar to the linear queue. It is similar to what? Simple queue or the linear queue, except that the last element of the queue is connected to the first element of the queue. We can represent it like this. Yes. last element of the queue will be represented in a first. This is 0, 1, 2, 3, 4, 5 and 6. Last element is connected to the first index value of the queue. This is also known as a ring buffer. As I mentioned, it also known as a ring buffer, as well as the ends are connected to another end. Both ends are connected. Last and the first ends are connected, so we call it as a ring buffer. This is all about the circular queue. Next, coming into the priority queue. Again, we have a priority. Priority means whichever the element have the highest value, that element has to be deleted first. That is called as priority queue. It is a special type of the queue in the data structure where every element has a priority. What we are giving? We are giving the priority to elements within the queue. Suppose some element occurs within some priority, they will be arranged according to the FIFO principle. While inserting, if I insert 15 after 5, it has to be arranged in the priority manner. Where 15 has to come? 15 has to come in between 20 and 10, right? So we have to shift this 5 here, then 10 here, then 15 here. So this how it will arrange itself once in the FIFO principle. Here we have two types of priority. One is ascending priority and descending priority. The example shows you about the descending priority. Ascending priority is nothing but the smaller number first, then larger number at the last. So that is a ascending priority. So this is a ascending priority what we have given. This is a descending priority. The highest priority value has to be deleted first. That is a priority based queue. Next, one more type of the queue what we have is double-ended queue. As name itself indicate, it will be ended in the both the side of the queue. That means you can either insert or delete at the one end, and that is a rear end, or you can insert or delete at the front end also. Both the operation can be done at the both side of the queue. That is called as double-ended queue or DEQ. Double-ended queue, insertion and deletion can be done from both the ends. The queue either from the front end or to the rear end. DEQ can be used in searching a palindrome, where the application of DQ comes when we are searching for the palindrome, whether the given string is palindrome or not. Then means that if we read the string from both the ends, it has to be displayed the same string. Like for example, what is the example for palindrome? Madam. D-A-M. So if you read from left to right, also it is a madam. If you read from right to left, also it is a madam. That such type of strings is called as palindromes. When we are implementing this type of DQ is when we are searching for the palindrome string. Here you can see the pictorial representation. This is our front end. This is our rear end. Both insertion can be done and deletion can be done at the front end. And similarly, insertion and deletion can be done at the rear end also. Okay, this is all about double-ended queue. We have some restrictions on the double-ended queue. We can put some restriction on the double-ended queue. What is that restriction? That is input restricted double-end queue and output restricted double-end queue. If we don't want to do insertion and deletion at the particular end, we can restrict the input of the queue. That is called as input restricted DQ. What input restricted? We are restricting the input not at the rear end. We are restricting the input. We can insert the element only at the front end but not at the rear end. That is input restrict. You can do vice versa also. You can restrict the insertion from rear end also. You can do either the way. You can insert at one particular point or one particular opening. Either it is a rear end or it is a front end. That is a input restricted queue. While come to the output restricted queue, we are putting a restriction on the output or to delete the element from the queue. Here what we are doing, we are deleting one particular end, that is rear end. We don't want to delete here from the front end. So we can put the restriction in either the way, vice versa. You can restrict the queue for deleting from the first front end, or you can restrict the queue or deletion can be taken care by the rear end. So either the way you can implement the restrictions on the double-ended queue. This is all about different types of queue. Let us see what all the different operations we have on the queue. As we have a different operation and arrays, stack, and let us see what is the different operations we have on a queue. So similarly, insertion, deletion, and we have a overflow and underflow condition, and apart from that we have a peak condition, peak operation. What this peak operation will do? Peak operation will only point to the front pointer element. It won't delete anything. NQ means inserting the element into the queue is called as an NQ operation. Operation is used to insert the element at the rear end of the queue. So we are discussing these operation with respect to the simple queue only, right? We are discussing these operations on the queue with the respect to the simple queue only. Okay, NQ is to insert the element into the queue from the rear end, and DQ is to delete. It performs the deletion operation from the which end? Front end. It performs the deletion operation from the front end. It also returns the element which has to be removed from the front end, and it returns the integer value. Whatever the value we have deleted, that has to be written back to the main program. That is the operation what we are doing in the DQ. Then coming to the peak, I have already told you, peak is just will be pointed by the front pointer. It in the queue but does not delete any element, which is a element that is pointing by the front pointer, that will be displayed by the peak operation. Apart from that, two more operation what we have is queue overflow and queue underflow. What is overflow condition? When the allotted memory is full, that time we cannot insert any element into the queue. That condition is called as queue overflow. And underflow means when there are no element, all the allotted memory is empty. We have not inserted any element into the queue. At that time we can call it as it is underflow. That is empty condition and is full condition. Next, we'll see how to insert an element at the rear end. So let us see what are the steps we should follow to insert the element at the rear end. We know that the item has to be inserted at the rear end. Which item I am inserting? I am inserting the value as 4. For this, what we have to do? We have to increment the R value, that is a rear pointer value, by 1. So if it is my queue, yes, so this is a front end, this is a rear end. I want to insert the element 4 into the rear pointer. So initially R will be pointing to nowhere. So increment the pointer of R by using R plus plus, or by using R is equal to R plus 1, right? So increment the rear pointer by 1. Now how the item has to be inserted after incrementing? What we have to do? We have to take the queue as a, and we have to put the value 4 on that. Now we are what? Assigning the value to this particular location. That is what? How the item can be inserted at the rear? This is achieved by copying the item to queue of R using the following statement. That is, item which element we want to insert, that will be copied into this particular position of R. We cannot insert any item where R has already reached queue size minus 1. That is what? Stack or queue full condition. If R is Q size minus 1, that represent Q full condition. At that condition, we cannot insert any element. So let us see the C code for this particular insertion from the rear end. So what we are doing, we are creating one function, insert at the rear. So insert rear function we are creating. What we are checking first, whether Q is full or not. Is full condition we are checking. For is full condition, R is equal to Q size minus 1. That is, if N minus 1 is there, so Q size minus 1, Q is full. So what we are printing? We are printing Q is overflow. We cannot insert the element into the Q and return back to the main program. If this condition fails, what we have to do? We have to increment the R pointer by 1. Increment the R pointer by 1 and assign the element into that particular rth position, Q's R position. So that's all we have to do. If it is a 4, 4 will be inserted at the particular position where R will be pointing. This is a C code for inserting the element at the rear end. Now coming into the deletion operation, how to delete the operation, where in which end we are deleting the element? From the front end we are deleting the element, right? So deletion operation has to be taken care by the front end in a Q. This can be achieved by accessing the front element. What we have to access? We have to access the element which is there at that front pointer position as shown below. How we are going to access? Print element deleted and percentage the Q of F, or you can write is item underscore deleted is equal to Q of F, right? Item underscore what the front end. So for example, this is your Q, right? Here we are having 3, 4, 5, 6 like this. This is a front pointer and this is a rear pointer. I want to delete this particular position. So front will be pointing to this particular position. Q of F is what? Q of F is equal to 3, right? So this 3 value will be assigned to where? Item deleted. Delete is equal to 3. So that 3 will be assigned to this particular item delete. After that, what we have to do? We have to print that particular item, which item we have deleted. That's why we are using a percentage D. Either we can write it in the single statement or I can write it in the 2 statements. After this, I should write printf deleted item is equal to percentage D, comma, item deleted slash n, right? Either you can use a 2 statement or you can use it directly in the single statement. After that, what we have to do? We have to increment the front pointer. Now this is deleted. So front should be pointing to where? Front should be pointing to the next element of the Q. So we should increment this front pointer to the next element of the Q. So what we are doing? We are incrementing either by F is equal to F plus 1 or F plus plus. So either the way we can do. The above 2 statement can be written using a single as shown below. That is what the single statement what we have written. We are incrementing the F pointer directly in the printf statement. We can reduce the number of code by doing this. Observe that each item has deleted the index variable F is incremented so that it always contains the position of first element in the Q. Finally, when the Q is empty, the value of F will be greater than R. So if this is a Q, we are deleting all the elements from the front and rear. So front will be pointing and now the value of F is greater than R. When it reaches to this position, we can say the Q is empty. There are no elements in the Q. So once the greater than R, it is not possible to delete any element. This condition is called as queue underflow condition. So what we have to check? We have to check whether the elements are there in the queue to delete or not. Let us see the C code for this particular deletion operation. We are writing the function for deleting. So in which end we are deleting? We are deleting from the front end. So what we have to check? First condition, we have to check whether the queue is in underflow condition or not. For that, what we have to check? F is greater than R. If F is greater than R, that means there are no elements in the queue. So it is in an underflow condition. If this condition fails, what we have to print? We have to print the element deleted. Which element I am deleting? Which is there in this particular position. After deleting that, I am incrementing that front pointer. This is what the C code for deleting the element from the queue at the front end. So next, one more operation what we have is display the content of queue. How to display the content of? As we are displaying the content of array, the similar way we have to display the content of queue. How many elements are there in the queue? That is how we are designing. Consider the following situation where 4 elements are inserted already. 4 elements we have in the queue. That is, what are the 4 elements we have? 20, 30, 40 and 50. Rear and front. So I want to print all these 4 elements. Usually the contents of the queue are displayed from the front end to moving towards the right. So how we are going to give? Like this, moving from left to right, moving from front to rear position. That is, ends at the rear position. What we have to do? We have to print that particular integer value or a particular element which is there in the first queued index. First queue index, that is 20 will be printed, then 30, then 40 and 50 will be printed according to the statement given. Let us see the C code for this particular display function. What we are writing a function is to display. So we have to check whether queue is empty or not. How to check queue is empty? If there are no elements in the queue, how you can print the element or how you can display the elements? So first we have to check whether queue is empty or not. Some element is there in the queue to display or not. For that, we have to go with the condition where F is greater than R, means the queue is in underflow condition. So we cannot display any element from the queue and we are saying that queue is empty. If this condition fails, then what we have to do? We have to display. So what we are doing? We are using the for loop. So print all the elements of the queue. We are using the for loop. I will be pointing to which location? Front location. Because why? We are moving from left to right. That is from front end to rear end. So I will be pointing to the front and then I is greater than or equal to R. Till how long we have to traverse? We have to traverse till the rear end, right? So I is less than or equal to rear we have to traverse and each time we have to keep on incrementing the I value. So this printf statement is given within the for loop to display more than one element or to print more than one element. So this is about the display function, how to display the element of the queue. So that's all for today's session. Thank you.